We are going to start now lecture 3 of chapter 11, class 11 mathematics, conic sections. So in this lecture we will talk about ellipse. So in our previous lecture we have seen the definition of the parabola. Now we are talking about the definition of ellipse. We are saying we are given two fixed points f1 and f2, and we are interested in the locus of the points which are at a constant distance from the sum of the distance. We are talking about this pxy is there, any point is there. We are calculating the distance of p to f1, we are calculating the distance of p to f2, and we are talking about the sum of distances pf1 plus pf2, and this value should be equal to a constant. So all such points we are talking about, the locus of all such points, we are saying if this point is over here, this may be over here, this point may be over here. So the collection of all such point P, that represents an ellipse, and these 2 points f1 and f2, these are called the focus or foci. Foci is the singular and focus is the plural for foci. So we are saying this f1 f2, these are focus of the ellipse, and this locus, it is this locus we are talking about, this is the ellipse that we have. So some more terms related to ellipse there. First is the center of the ellipse. So we are saying the midpoint of the line segment joining the foci is called the center of the ellipse. So this f1 and f2, these are the two focus, and midpoint of these two, it is called the center of the ellipse. So we are saying OF1 is equal to OF2. Next we have is major axis. So the line segment through the foci of the ellipse and its end points on the ellipse is called its major axis. We are saying these are the focus f1 and f2, and we are talking about a line which is whose end points are lying on this ellipse, and this line is passing through the points f1 and f2. This line, it is called the major axis. Next term we have is the minor axis. So we are saying this is the center O, the line passing through the center O and which is perpendicular to the major axis. The line passing through the center O and perpendicular to the major axis, that is called the minor axis of the ellipse. Next term we have, it is vertices of an ellipse. So the end points of the major axis of an ellipse are called the vertices. So this A and B, in this case, these are the vertices of the ellipse. So when we are talking about an ellipse, we are saying the length of the major axis, we consider it is 2a. Length of the minor axis, we are saying it is 2. Similarly, for the distance between the foci, we consider it is 2c. These are just the notations we are talking about. Then length of the semi-major axis, we consider it is a, and length of the semi-minor axis, half of the length of the major axis and the minor axis, these are called semi-major and semi-minor axis. They are the way we generally denote them with A and B. Next is eccentricity of an ellipse. So we are saying the ratio C is to A. C is the, we are saying 2C is the distance between the foci. We are talking about, we have an ellipse over here. We know that how we have plotted this. This is f1, this is focus f2. These are the vertices that we have. These are the two vertices. This length we have, it is 2a. This length we are writing it is 2b. The half of this length we have, it is a. Half of this length we have, it is b. And this distance we are saying it is, this whole distance we are saying it is 2c, and half of this distance we are saying it is c. So eccentricity of an ellipse, it is c upon a. We are talking about eccentricity means it is the half of the distance between two foci divided by half of the length of the major axis, that is called the eccentricity. It is denoted by E, and this is always a constant quantity. We are saying this is always a constant quantity, and for ellipse in particular we have the value of the eccentricity. It always lies between 0 and 1, because this value eccentricity we are saying it is c upon a, and c is always less than a in case of ellipse. It is clear from this figure. So these are some terms we have related to an ellipse. Next is, in the given ellipse it is being given that AB is equal to 2a. This length we are saying it is 2a. CD is equal to 2b. This length we have it is 2b. F1, F2 is equal to 2c. We have to prove that a square minus c square is equal to b square. So to prove this, we are considering a point C on the minor axis, and clearly we have this line CO. This will be the perpendicular bisector of F1, F2. So if we join these points F1 to C and F2 to C, we have joined these 2 points. Now we have F1O that is equal to F2O that is equal to C. Further we have OC is equal to OD is equal to B. So we have 2 triangles over here. One triangle we are talking about, this triangle. So what we obtain from this is that this length we are talking about, this length we are saying it is equal to square root of c square plus b square, and this length is also equal to square root of c square plus b square. Now this point C, it lies on the ellipse. This point B, it also lies on the ellipse. So what we obtain is the sum of these two lengths. We are saying it is F1C plus F2C. This should be equal to F1B plus F2B, and this should be equal to constant. This is by the definition of the ellipse. We know that the distance from two fixed points, it is constant. So we can write F1O plus OB. We are talking about F1O plus OB means we are talking about this whole length, plus OB minus OF2. When we are saying OB minus OF2, it means we are talking about this portion. These are the lengths we are saying. This is F1B and this is F2B, and this value is equal to F1C plus F2C. So if we substitute these values over here, from this we are getting C plus A minus C, that is equal to the value of F1C plus F2C. We have it is 2 times the square root of C square plus B square. So this C and C gets cancelled, and we get A is equal to square root of C square plus B square, and this implies us A square minus C square is equal to B square, and this is what we have to prove. So we have used the result over here, that we have considered a point, this point on the minor axis, we have considered this point B on the major axis, we have calculated the distance of F1, F2 from these points, and we have used the definition of the ellipse, that the distance should be, the sum of these distance should be constant, and we have substituted the values to obtain this relation, that for an ellipse we have A square minus C square is equal to B square. Now the next thing we have to do is to find the standard equation of an ellipse. So in the first part we are saying, suppose an ellipse is given whose semi-major and semi-minor axis, they are of length A and B. So corresponding to these 2 points, we can find another point C. We can find a number C such that C square is equal to A square minus B square. It is given that A is greater than B. And from this C, we are saying we obtain 2 points. One is the point minus C0 and second is the point C comma 0. We can obtain these 2 points, which will be the focus of the given ellipse. These are the focus of the given ellipse. So we want to find the equation of the ellipse. It means we want to find the locus of the point pxy which lie on the ellipse, such that their distance from f1 and distance from f2, sum of these two values, that should be a constant, and that constant should be equal to 2 times a. This thing is coming from the definition of the ellipse. It means we are saying pf1, p we have, this f1 we have obtained, plus pf2, that should be equal to 2 times a. So if we calculate the length pf1, its value is square root of x plus c square plus y square plus square root of x minus c square plus y square, that is equal to 2a. So we can write it in the form square root of x plus c square plus y square is equal to 2a minus square root of x minus c square plus y square. If we square both sides of this equation, we obtain the equation in the form this form. It is 4cx minus 4a square, that is equal to minus 4a square root of x minus c square plus y square. And if we again we first divide it with 4a and again square the both sides of this equation, and this equation will come to the form, it is x square into a square minus c square divided by a square plus y square is equal to a square minus c square. So we are getting x square over a square plus y square over a square minus c square, that is equal to 1. And we know that the value of a square minus c square, that is equal to b square, the length of the semi-major axis, that is b. So the equation of the ellipse, that will come in the form x square over a square plus y square over b square is equal to 1, where b square is equal to a square minus c square. So we are saying that every point on the ellipse satisfies the equation x square over a square plus y square over b square is equal to 1. Next, we are talking about the converse part. So we are saying, suppose a curve is given and its equation is x square over a square plus y square over b square is equal to 1, and pxy be any point which lies on this curve. Then from this equation we can write y square is equal to b square by a square into a square minus x square, and we know that a square minus b square is equal to c square. So we are saying let f1 and f2, these are two fixed points on the x-axis. Then if we calculate the length pf1, the length we will have it is square root of x plus c square plus y square. In place of y square we can substitute this value, and we are getting it is square root of x plus c square plus b square by a square into a square minus x square. And on solving this value, this reduces to the form, it is a plus cx over a. Now if we calculate the length pf2, the answer we will obtain, it is a minus cx over a. Using the similar calculation, we obtain the answer in this form. So if we calculate the length pf1 plus pf2, we obtain the total answer as 2a. And this thing proves that we are talking about this point P. We have any point on the ellipse. These are the two fixed points we have, f1 and f2. So what we have proved is that the distance of this point P from two fixed points, it is constant 2a, that is length of the major axis. So we are saying the curve, the given curve is an ellipse. Next we have is different cases over here. First is the horizontal ellipse. So in the given equation of an ellipse, if the coefficient of x square has the larger denominator, then its major axis lies on the x-axis. We are talking about x square over 3 square plus y square over 2 square equal to 1. So the denominator of x is larger than the denominator of y. So we are saying this ellipse will have the major axis along the x-axis. So in general we are saying x square over a square plus y square over b square is equal to 1 is horizontal ellipse if a square is greater than b square. Next we have to calculate is the lattice rectum of an ellipse. So it is, the definition is again the similar to what we have studied for the parabola. We are saying the lattice rectum of an ellipse is a line segment perpendicular to the major axis and passing through any foci with end points lying on the ellipse. So this ellipse is given, f1 and f2, these are two focus. So we are talking about the line perpendicular to the major axis and passing through these focus, and their end points, they lie on that ellipse. This is the lattice rectum. So we have to calculate the length of the lattice rectum. So to find the length, we are considering this length is L. This focus is at a distance of C. So clearly this point P over here, this end point over here, its coordinates, they are C comma L. These are the coordinates of the point P. And the coordinates of this point Q, that will be C comma minus L. Now we are saying that this point P, it lies on the ellipse with the equation x square over a square plus y square over b square is equal to 1. It means it will satisfy this condition. So what we get is that c square over a square plus l square over b square is equal to 1. So from this we can obtain that L square over B square is equal to 1 minus C square over A square. This is equal to A square minus C square over A square. This is L square by B square. And the value of C square, we know it is, in place of C square, we can write it is A square minus B square. So we are getting L square is equal to B raised to the power 4 over A square. So this implies us, we are saying L we are considering to be positive, it is length over here. So we are saying L is equal to B square over A. So the length of the lattice rectum of an ellipse, it is 2B square over A. The length of the lattice rectum means we are talking about this complete length. This part, it is B square over A. So double of this will be 2B square over A. So this is the length of the lattice rectum of an ellipse. So we summarize the results that we have studied till now. First is the standard form of the horizontal ellipse. It is x square over a square plus y square over b square is equal to 1, where 0 is less than b is less than a. 2a and 2b, these are the lengths of the major and the minor axis. The focus of this ellipse, they are minus c0 and c0. Vertices of this ellipse, they are minus a0 and a0. Vertices means we are talking about the major axis, and the end, where the points where the major axis meets with the ellipse, they are called the vertices of the ellipse. The center of this ellipse will be 0, 0. It is the midpoint of the two focus we are talking about, two foci we are talking about. Then we have equation of the major axis, it is y is equal to 0, and minor axis, it is x is equal to 0. Then we have the length of the lattice rectum, it is 2b square over a. Lattice rectum means we are talking about a line which is perpendicular to major axis, and its end points, they lie on the, it passes through the focus, and end points, it lies on the ellipse, that is the lattice rectum, and length of the lattice rectum will be 2b square over a. And eccentricity E, we are saying it is C by A. This is by the definition we are talking about, and that is equal to square root of A square minus B square over A, and this value is clearly less than, this lies between 0 and 1 because C is always less than A in case of ellipse. Similarly, if we are talking about the vertical ellipse, the equation will be x square over b square plus y square over a square is equal to 1, where 0 is less than b is less than a. Or if we are writing x square over a square plus y square over b square is equal to 1, we are writing now b is greater than a, then that will be a vertical ellipse. The center is 0 0. Vertices are now, these are the two vertices that we have, because this is the major axis now. This is the major axis, this is the minor axis. The length of the major and minor axis, again they are 2a and 2b. When we are talking about the foci, they are 0 comma minus c and 0 comma c, or you can write it is 0 comma minus ae and 0 comma ae. When we are talking about the equation of the major and minor axis, it is x is equal to 0 and y is equal to 0. Again, length of the lattice rectum, it is 2b square over a, and eccentricity e, it is c is equal to e is equal to c over a, that is the eccentricity of this ellipse. So you can consider the equation in any form. You can consider the equation in the form x square over b square plus y square over a square is equal to 1, with 0 is less than b is less than a. All the results will come in this form. If you are considering the equation in this form and you are writing b is greater than a, then these results will change accordingly. So based upon this, the first problem we have is find the length of major and minor axis, coordinate of vertices and foci, the eccentricity, length of lattice rectum of the ellipse given by the equation x square over 16 plus y square over 9 is equal to 1. So clearly this is an horizontal ellipse because we are having a is greater than b over here. This we are talking about, it is of the form x square over a square plus y square over b square is equal to 1. So it is an horizontal ellipse. So we are saying if we plot it over here, it is in this form. The value of a we have that is equal to 4, value of b we have that is equal to 3. It means this point we have it is 4 comma 0, this point we have it is minus 4 comma 0, this point we have it is 3 comma 0, this point we have it is 0 comma minus 3, this point we have it is 0 comma 0. Now from the value of a and b, we can calculate the value of c. We know that c square is equal to square root of a square minus b square, and it comes out to be, this is value of c, not square of c, it comes out to be root 7. It means the focus of this ellipse, they are root 7 0 and minus square root 7 comma 0. When we are talking about the length of the major axis, it is 8 units. Length of the minor axis, it is 6 units. We have seen the coordinate of the vertices, length of the major and minor axis, coordinate of the foci. Then we have to calculate eccentricity. We know it is c by a. The value of c, it is root 7. The value of a, it is 4. So we are saying the eccentricity we have it is square root 7 by 4. And the length of the lattice rectum, the formula we have it is 2b square by a, and the answer we get it is 9 by 2 units. This is the length of the lattice rectum of this ellipse. Next question we have is find the length of major and minor axis, coordinates of the vertices and foci, and eccentricity, length of lattice rectum of this ellipse. So we can write it in the form, if we divide this whole equation by 144, we obtain it is x square by 36 plus y square by 16, that is equal to 1. We have divided it from with 144 and we have written it in this standard form. So from this again we can see this 36 is greater than 16. So again it is an horizontal ellipse, and the value of a we have it is 6, the value of b we obtain that is equal to 4. So c is equal to square root of 36 minus 16, that is equal to root 20, that is equal to 2 root 5. So we are saying if we plot this ellipse over here, these endpoints we have, this is 6 comma 0, this is minus 6 comma 0, this is 0 comma 4, this is 0 comma minus 4, this is 0 comma 0. Then we have 2 points over here. This point we have it is minus 2 root 5 comma 0. This point we have it is 2 root 5 comma 0. These are the focus that we have. We have seen the vertices. These are the two vertices. Minus 6 0, 6 0 are the vertices. These are the two focus. Then length of the major and minor axis. The length of the major axis, that will be 12, and length of the minor axis, that will be 8 units. Then we have to calculate the eccentricity E, that is C by A, that is equal to 2 root 5 by 6, that is equal to root 5 by 3. And last thing we have to calculate is length of latus rectum. So length of latus rectum, the formula we know it is 2b square by A. So this value comes out to be 32 and 6. So we get it is 16 by 3 units. So this is the length of the latus rectum in this case. Now the next we have is find the length of the major and minor axis, coordinates of the vertices, foci, eccentricity and length of latus rectum corresponding to the ellipse with this equation. So if we look at this equation, the denominator of y is greater than denominator of x square. So we are saying this is a vertical ellipse. So we use the equation in the form, we compare it with x square over b square plus y square over a square is equal to 1. So we are saying the value of b we have, that is 2, and value of a we have, that is 6. So c we have it is square root of a square minus b square, and we are writing its value is root 36 minus 4, that is equal to 4 root 2. So on this ellipse we can see this point it is 0 comma 6, this point it is 0 comma minus 6, this point it is 0 comma minus 2, this point it is 0 comma 2. The two focus that we have it is 0 comma 4 root 2, and this is 0 comma minus 4 root 2. These are the two focus that we have. Then the length of the major axis we have it is 12. The length of the minor axis we have it is 4. To calculate the eccentricity we have the formula, it is C by A. So we get it is 4 root 2 by 6, that is equal to 2 root 2 by 3 units. And units are not there. This eccentricity does not have any units, so there are no units over here. And last we have to calculate the length of latus rectum, L, that is 2b square over A. So the answer we obtain in this case, it is 2 into 4 by 6, that is equal to 4 by 3 units. So these are the things that are being asked in this problem. Next is find the length of the major and minor axis, coordinate of vertices and foci, the eccentricity, length of latus rectum of the ellipse given in this form. So again we divide this equation by 100. So we obtain it is x square by 25 plus y square by 100 is equal to 1. Clearly this value is greater. So we compare it with x square over b square plus y square over a square is equal to 1. We get a is equal to 10. We get b is equal to 5. From this we get c is equal to square root of 100 minus 25, that is equal to 5 root 3. So this is an vertical ellipse. This coordinate it is 0 comma 10. This coordinate it is 0 comma minus 10. This coordinate it is minus 5 comma 0. This coordinate it is 5 comma 0. This coordinate it is 0 comma 5 root 3. This coordinate it is 0 comma minus 5 root 3. We can calculate the length of the major axis. It is 20 units. Length of the minor axis, it is 10 units. We have seen the focus. These are the two focus. These are the vertices. Major and minor axes are there. Then we have to calculate is eccentricity E, that is C over A. So it is 5 root 3 by 10, that is equal to root 3 by 2. and length of the latest rectum we have formula 2b square over a, and the answer we get that is 5 units. So these are the things that are required to be calculated in this problem corresponding to this equation of the ellipse. Next is find the equation of the ellipse whose vertices are, these are the vertices given, and foci is given over here. So corresponding to this vertex, the value of a is given to be 5. From this focus we obtain the value of c is given to be 4. So we obtain the value of b, that is equal to 25 minus 16, that is equal to 9. This is the value of b square. So the value of b we have that is equal to or we don't need value of b, we are saying b square is 9, a square we have it is 25. So the equation, the required equation of the ellipse, that will be x square over 25 plus y square over 9, that is equal to 1. Clearly this is an horizontal ellipse. Next is find the equation of the ellipse whose focus is given. This is the value of c is given to be 4. Eccentricity is given to be 1 by 3. We know that a is equal to c by e. So this implies us the value we obtain it is 4 over 1 by 3, that is equal to 12. And the value of b we obtain, b square we know it is a square minus c square, and it comes out to be 144 minus 16, that is 128. So the equation of the ellipse we will get it is x square over 144, that is a square, plus y square over 128 is equal to 1. So this is the equation of the ellipse. Again this is an horizontal ellipse because the foci they are lying on the x-axis. Next is find the equation of an ellipse whose major axis lies on x-axis. It means it is an horizontal ellipse and passes through the point 4, 3 and 6, 2. So it is horizontal ellipse. So we are considering the equation in the form x square over a square plus y square over b square equal to 1, where we are saying that a square is greater than b square. Now the ellipse passes through these 2 points. So we obtain two equations. One is 16 by a square plus 9 by b square is equal to 1. Second is 36 by a square plus 4 by b square is equal to 1. So these are the two simultaneous equations that we have to solve. And to solve these equations, we substitute 1 by a square is equal to u, 1 by b square is equal to v. So these two equations will become, it is 16u plus 9v is equal to 1, 36u plus 4v is equal to 1. If we solve these two equations, we obtain the values as, we are obtaining the value of v is equal to 1 by 13, and we are getting the value of u is equal to 1 by 52. And by using these substitutions, we are getting a square is equal to 52 and b square is equal to 13. So the equation, the required equation of the ellipse, it is x square over 52 plus y square over 13, that is equal to 1. So the main thing over here is to solve these linear, to convert these equations to the system of linear equation, solve these values, make the required substitutions, back substitution, and obtain the equation of the ellipse. Next is find the equation of the ellipse, the endpoints of whose major axes are plus minus 3. It means these are the values of a, and the ellipse that is given to us, it is the horizontal ellipse. The value of a is given to be 3, and endpoints of the minor axes are 0, plus, minus 2. It means the value of the b that is given to be 2. So we are saying the equation of the ellipse will be x square over a square plus y square over b square is equal to 1. So this is the required equation of the ellipse satisfying the given conditions. Next is find the equation of the ellipse whose center lies at the origin, major axis lies on the x-axis, the eccentricity is 2 by 3. The length of the latus rectum is 5 units. Length of the latus rectum is value of L is given to be 5, and this is equal to, we know, 2b square by A. And eccentricity, the formula for eccentricity, we know it is equal to C by A. So we have to calculate the value of, we want to find the equation of the ellipse. It means we want to calculate the value of A and B. So we start with the value of latus rectum. We are writing it is 5 is equal to 2b square over A, and the value of B we know it is A square into 1 minus E square divided by A. So from this what we obtain, this A gets cancelled over here, and we are left with A is equal to 5 by 2 times 1 minus E square. The value of E is given. And if we substitute this value of E over here, we obtain it is 5 by 2 into 1 minus 4 by 9, and the answer we obtain it is 9 by 2. This is the value of A that we have. Now B square is equal to A square into 1 minus E square. So what we get from this, it is 81 by 4 into 1 minus 4 by 9. So answer we get it is 45 by 4. So the value of A square we have it is 81 by 4. Value of B square we have it is 45 by 4. So the equation of the ellipse we have it is x square over 81 by 4 plus y square over 45 by 4, that is equal to 1. And if we simplify this value, the final equation we obtain it is in the form 20x square plus 36y square is equal to 405. Next is find the equation of an ellipse whose vertices are 0, plus minus 13. It means it is a vertical ellipse, and focus they are given over here. So we are writing the equation in the form x square over b square plus y square over a square is equal to 1. The value of a is given to be 13. The value of c is given to be 5. So we can calculate the value of b. B square is a square minus c square. It is equal to 169 minus 25, that is 144. So the value of b we are writing it is 12. If we are talking about the length, it is 12. So the required equation we obtain, the required equation will be x square over b square, that is 144, plus y square over a square, 13 square is 169, that is equal to 1. So this is the required equation of the ellipse. Next is find the equation of the ellipse with focus this and length of whose minor axis is 16. So focus is given, it means the value of c is given to be 6, and the length of the minor axis is 16. It means the value of b is given to be 16. We are writing the equation in the form x square over b square plus y square over a square is equal to 1, because the foci they are lying on the y-axis. So it is an vertical ellipse. So equation is in this form. So we obtain the value of b is equal to 8. So we obtain a square is equal to c square plus b square, that is equal to 36 plus 64 is equal to 100. So the equation we obtain by substituting the values over here, we are writing x square over the value of b we have it is 8. So it is 64 plus y square over a square is 100, that is equal to 1. So this is the required equation of the ellipse. Next is find the equation of the ellipse whose foci are this and length of whose major axis is 20. So the value of c is given to be 5. Again the foci it is lying on y-axis. So it is a vertical ellipse. So the equation we have it is x square over b square plus y square over a square is equal to 1. The value of c is there, and the length of major axis means the value of 2a is given to be 20. It means a is given to be 10. So the value of b square we obtain, that is equal to a square minus c square, that is equal to 100 minus 25 is equal to 75. So we have obtained the value of b square as 75. We have obtained the value of a square as 100. If we substitute these values in this equation, the final equation we will get, it is x square over 100. It is over b square. So it is over 75 plus y square over 100, that is equal to 1. So this is the required equation. Next is find the equation of the ellipse for which eccentricity E is 4 by 5 and whose vertices are 0, plus minus 10. So clearly this is a vertical ellipse we are talking about, and equation will have x square over b square plus y square over a square is equal to 1 with a square greater than b square, and the value of a is given to be 10. These are the vertices that we have. Further, E is given to be 4 by 5. So the value of C we obtain, that is A into E, that is equal to 8. So the value of B we can obtain, it is square root of A square minus C square, that is 100 minus 64 root 36, and it comes out to be 6, or we are saying B square is equal to 36. So the values now we have, it is B square is 36, A square is 100. So substituting both these values in this equation, we obtain x square over 36 plus y square over 100 is equal to 1. Next is find the equation of the ellipse with the center at the origin. Major axis on the y-axis. It is a vertical ellipse. It is x square over b square plus y square over a square is equal to 1. And passing through the points 3, 2 and 1, 6. So when it is passing through these 2 points, we will have 2 equations. First is 9 over b square plus 4 over a square is equal to 1. Second is 1 over b square plus 36 over a square is equal to 1. If we substitute 1 by b square is equal to u and 1 by a square is equal to v, we get 9u plus 4v is equal to 1 and u plus 36v is equal to 1. And on solving these 2 equations, we have these 2 are the linear equations we have, we will obtain v is equal to 1 by 40, that is equal to 1 by a square. So this implies us a square is equal to 40. We obtain u is equal to, on solving these values, you will obtain u is equal to 1 by 10, that is equal to 1 by b square. So this implies us b square is equal to 10. Substituting both these values of a square and b square in the given equation, the final answer we obtain, it is x square over 10 plus y square over 40, that is equal to 1. So this is the required equation of the ellipse.